Jacob, you wanna make a bet?
Yeah, of course, Garrett. I'm always up for making some money.
Alright, I'll bet you $10 that you can't make this needle float in the water.
Are you kidding me? That's easy. This little thing, there's no way it could float. You see? No way.
Alright, well, I learned a cool little trick in my fluids mechanics class today.
Oh, yeah?
That if just a little bit of patience, you're real gentle. What do you think about that, Jacob?
What, Garrett? How did you do that?
Well, my friend Dane here will explain to you a little bit about the science to prove you even more wrong.
Oh.
So what we need to do is treat this system as a static system. The needle on top of the water has a weight force going down with surface tension going up from the water. Sum of the forces in the Y is equal to force of the surface tension in the positive minus W in the negative, equal that to 0 to make it static. The W is equal to the volume times the specific weight of stainless steel. Surface tension is equal to sigma, which is the surface tension times 2L cosine theta. Theta in this case is approximately 0, which means that the cosine of theta would be equal to 1. So we solve for D to figure out what diameter the needle should be. The diameter comes out to be 1.57 in the static case, which means that the diameter of the needle must be less than 1.57 millimeters. Diameter of the needle is actually 0.55 millimeters, and the length of the needle is 2.75 millimeters. Solving the math, this comes out that the force of the surface tension is greater than the weight force. So the needle will float on top of the water since the surface tension is pulling back up on it.
Alright, so if you think that's pretty cool, another way that you can try to fool some people is if you add a little bit of soap to the needle while it's floating. The soap will actually act, it will decrease the surface tension, so then the weight of the needle will be more, so it'll actually fall down.
Wow. Crazy.
Now let me show you my favorite thing to drink, pepper and water.
Hey, I'm gonna show you an even better recipe.
What? Whoa, what are you doing with that?
Add a little bit of soap to that.
Whoa!
What do you think about that?
That's amazing, but you ruined my drink.
It's not ruined. My friend Jacob here will explain what's going on.
So what's really happening is Garrett is adding a surfactant to the bowl of pepper. Now, when you have a normal mass of water, it's held together through equal and opposite forces of surface tension, keeping it together, and the pepper is just floating on top. But when you add a surfactant, also the soap, the area where the surfactant disperses to is lowering that surface tension. So the regular mass of water's force is higher than the surface tension in the middle, and it pulls the pepper away. Wow, Garrett, I sure learned a lot today. You beat me fair and square.
Welcome, Jacob. All right, it's 5:30. I think it's enough learning for
Yeah.
today. Let's get out of here.
I want to go home.
All right.